Okay, so this is going to be a final question for this series of videos. What you have here is it says a cylindrical tank is oriented vertically. A cylindrical tank oriented vertically is 10 meters high and has a radius of 2 meters. 10 meters high. Now the tank is filled with water. The density of the water is 1000 kilogram per meter cube to a depth of 8 meters. So the tank is filled with water to a depth of 8 meters. Now we're told to find the work needed to pump all the water out of the tank. So the very first thing here it says plot the figure and show which volume element you'll be using for the integration. So what it just says is, are you going to be using the horizontal slice or the vertical slice? Are you going to be using the horizontal slices or you'll be using the vertical slices? Which exactly you'll be using to evaluate the integral that's necessary for finding the work needed. And the next one says set up the integral to find the work. Specify all the units of terms inside the integral. Okay, there are so many things going on in here, but so like again, the best thing you do is you begin by handling this question a step by each. So the first thing we have here is a cylindrical tank is oriented vertically and it is 10 meters high. So let me stop here, let me evaluate this. So to interpret that, it says a cylindrical tank oriented vertically is 10 meters high. So let me draw a cylindrical tank. So this, again, nothing fancy, just something to help us understand the problem. So this is my cylindrical tank. So I've been told it is 10 meters high. So this is my so this is what I have. This is my cylindrical tank. So it's oriented vertically, and then it says it is 10 meters high. So I need to interpret that. So it says from here to here is 10 meters, from here to the bottom. So this is 10 meters. The next one says has a radius of 2 meters. So I'm done with that. Has a radius of 2 meters. So if this is the axis, so what it says is from here to here is 2 meters. That's exactly what it says. Then it says the tank is filled with water to a depth of 8 meters. Now note, to a depth of 8 meters. So not filled to the brim, but to a depth of 8 meters. So let's say this is filled with water. Let's say this is our water, and it has a height of 8 meters. That's what it says. It has a height of 8 meters. So let's go on. Now the density of water is being given to be 1000 kilogram per meter cube. Now find the work needed to pump all the water out of the tank. So the very first thing says plot the figure. Now we've plotted the figure, then show which volume element you will be using. So again, the strategy that we'll be using here is this. So we'll find the work needed to pump a slice, we'll find the total work, and then we'll make exact. So like the previous videos I did. So we're going to be using the same abbreviation, SSI. You slice, you sum, and then you integrate. That's what we're going to be doing. So it says which volume element will you be using for the integration. Now let me explain this part very well. You want to find the total work needed to pump this whole water out of the tank. Now to do this, what I'm going to do is I'm going to slice this. I'm going to slice the water. I'm just going to pick a particular slice of the water. So this is the slice I'm picking. Now you note the slice I've picked here has to go through this distance from here to here. To pump this out of the tank, it has to cover this distance from here to here. So let's call that distance, let's call that h. And let's call this, we'll call the height of this slice, let's call it delta h. Now when we bring this out, so this is what you have, the slice of water has a cylindrical shape. So this is the shape it has, and from what we have here, this is delta H, and again the height, sorry, the radius is 2. So you recall the strategy. So we want to start by finding the work needed to pump a slice. That's what we want to do. So what I'm going to do now is, what's the formula for work? So we know the formula for work is force times distance, right? So in other words, the work done needed to pump this slice of water is just going to be the force times, now the distance which the slice has to go through is h. It has to go through this distance here, this distance h here. So my d is just going to be h. Now how do I find f? So my work is force times distance. So the change in work, that is the work needed to pump the slice, is force times the distance. So how then do I find h? How do I find f? Well, you recall that the formula for f is mass times. So let me just label this. So this is 1. I want to find f now. So the formula for f is mass times acceleration due to gravity, and that's mass times g. But then how do I find m? So again, you've been given your density. This is your density here, kilogram per meter cube. That is kilogram mass all over meter cube, which is volume. So that's the formula for density. So your density equals mass divided by volume. So, and we want to find m so that we can evaluate f, and if we can evaluate f, we'll be able to evaluate the work done. So what you have here is, we want to find m, so we'll cross multiply. So my my m is just going to be the density times the volume, and the volume you have here is the volume of this object here. You know, this is a cylindrical shape, so it has a volume of, so the volume of this shape is pi times the radius square, that is 2 squared, times the height. The height is delta h. So this is what we have, and so that tells me that my mass is just going to be the density. So the density is the density we obtain here is 1000. So we can come here. So the density is 1000 multiplied by the volume. The volume is pi times 4 times delta h. So now I have my mass. Now since I have my mass, I'm going to plug in my mass in here. So this tells me that my force, you know, our aim is we want to find the force. So my force is just going to be, so this is going to be pi 4 times delta h, then times 1000 multiplied by g. And what's our g? Now if you go to the problem statement, we've been given the g to be 9.8 meters per second square. So multiplied by 9.8. So when you multiply all this out, what you're going to have is you're going to have pi. Now 4 times 1000 times 9.8 is going to give you 39,200, then multiplied by delta h. So anyway, this is my f. So now I can come back here. You recall our aim is you recall our aim is we wanted to find the work done, and the work done is f times h. We know h, but how do we find f? Now we have gotten f. So I could rewrite this whole statement here. I bring it here. So my delta W equals, so my force, which is now pi times 39,200 times delta h, then times h. So this is the work needed to pump the slice. So I could just rewrite this in like this. You have pi 39,200 times h, then times delta h. So this is the work needed to pump the slice of water. So the next thing is you sum. That's the total work. So the total work is just going to be the sum of everything you have here. So pi 39,200h times the other h. So then the next is you want to find the exact work. The exact work. Now this is a little tricky. It's a little tricky here because what you have here changes to an integral sign. Then you have pi, you have 39,200, you have h. Then what you have here changes to dh. Now what is going to be your limit of integration? Now watch this. You'd observe this. What you're summing, this is your h. Now your h is going to run from where to where? If you look at this point here, it's like you're dividing the whole piece of water. You're dividing this here, and you want to begin to sum all the slices. So by the time if you start summing from the very first slice, if you look at the very first slice here, what is the height? The height of this slice is going to be from here to here. That's for the first slice. And if from here to here is 8 and the total height is 10, then here is going to be 2. So that tells me that the beginning, that is my first h, is going to be 2. And then my last h, that is the last slice of water, would have to cover what distance? Would have to go from here to here. That is, it's going to go from this point here up to this point here. So for the last one is going to be 10. Again, what you have here is from h, you go from h equals 2 to h equals 10. So that tells me my limits of integration is from 2 to 10. And when you evaluate this, this is just going to give you 1881600 pi. So this is in Newton meters or in joules. So this is your final answer. So this question is kind of interesting. So if you have any problem, feel free to drop your questions in the comment box below.